All right, I just wanted to give a visualization on how I've been using AI currently to further research. So, a little bit of context. I've been assigned to work on this paper, which is about the optimization of our powder doser. So, how can we use control theory and Bayesian optimization to optimize our powder doser to dispense quickly and accurately for different powders? And I've always been very interested in control theory, but I haven't had a chance to take the controls class, so I don't know a lot. Um, and so I started this this paper by just trying to research random topics on controls, optimal control, linear quadratic regulators, Kalman filters, which I'll talk about more. And I wasn't really getting anywhere useful because I didn't have any direction. So I took a step back and I met with other members of the lab who have some control knowledge and basically learned that for this kind of um, device, the powder dispenser, it's going to be best to use something along the lines of a bang bang controller. So um, I had never heard this term before, but essentially it means you have your current state and you have your goal, and you're just moving towards your goal as quickly as possible, and then stopping at the right point so that you end up right as close to the goal as possible. And so logically, I can say, okay, well, I understand that what that would look like for the powder doser is it's spinning and it's at a high tilt angle for as long as possible um, until it needs to stop right at the goal. So I just tell Claude, hey, we need to run some tests on the powder doser. The only reason we can do this is because we have spent months, myself and other lab members, as well as my professor, on developing this powder doser that has the ability to interface with a scale and something that we can connect to remotely via tailscale SSH. And we used a lot of AI in developing this, but it was important that we understood how it worked as well. And because we took the time to understand it in the development process, we know how to control it, but we don't have to spend all this time manually controlling it ourselves. So sorry, I went off on a little tangent there, but so I tell Claude, all right, just dispense powder as fast as you can and do it until the scale reads a certain mass and then stop. And give me some results from this information. Because this is what a bang bang controller is going to be, but we need to know what the behavior of the powder is. So we do that, and it shows that, it dispenses and then it hits this threshold, and then it stops all actuation, but it continues to dispense powder until it levels off, right? So in another issue, I talk to Claude about wanting to use a bang bang controller. Now, once again, I don't know really anything about this control law. So I just tell it we want to use this with this controller in mind, outline tests that we can run on our setup that will gather the right data we need, and what our predictor would look like. And it goes through this long description, and it mentions something called a Kalman filter. Like I just mentioned, I don't really know what a Kalman filter is. So after reading through what it's given me, I just ask, can you go into more detail on how this three-state Kalman filter works? Would the data found in this test be useful? So then it gives me a step-by-step look at how this Kalman filter works. Here's our states, here's how they change with each time step. And so I'm starting to gain a little bit of an understanding. I'm starting to be able to give my own input. It would be best to estimate the rate live inside each dose as opposed to using the physics model for every step. So I give it some information. I tell it to set up some more tests so that we can properly quantify our states. And then the process just keeps going like this. And eventually I wrote some code for how the bang bang solution would work. So I'm able to open this code, and side by side, I'm able to ask it questions about specific things in the code I don't understand. And so it's a very aimed approach at learning. I'm not learning a very broad spectrum of control. I'm learning things specific to what my paper needs. And I think that's how research should be. We go to school to learn a broad spectrum of information, and we don't go very deep into any of it. But in research, we should expect to focus on something very specific for a long amount of time and learn it really well. And so I think in that sense, this has been very helpful. I can ask very specific questions and it can get back to me within seconds with information on it. And I find that very useful. I think the main caveat to using AI is the risk of becoming complacent, which was talked about in the group meeting. Sometimes it could be easy for me to see that a test didn't run right and just say, hey, that went wrong, and not take the time to look into why it went wrong and what needs to be fixed. But overall, I feel like I have been learning from this, but I very well could have not learned a thing and just said, hey, do what you need to do to set up this bang bang controller you speak of. So really it's on us whether or not we use this to learn or not. Either way, AI is going to know mostly how to solve these problems and how to research other papers to make sure that it's doing things that are consistent with the industry. We can't gatekeep it from knowing how to do things by forcing ourselves to do them on our own. But we can learn alongside it. So I just wanted to give a visualization of how I've been using it. So thank you.